Hey, what's up? This is Frederik Steinmetz, and this is the second part of the Praying Mantis tutorial. And this time we're actually gonna have a look inside cycles. This is what I came up with so far. The unbiased renderers, I think, Cycle and LuxRender, are both very, very good when it comes to shiny materials and when it comes to transparent materials and caustics, but they don't have any presets, or they don't seem to anticipate the very complex surface material of an insect. What I want is part of the insect, for example the legs, to be translucent, part of it to be shiny, and part of it to be something in between. So I have to come up with a lot of workarounds which I want to share with you. And also, this is not a perfectly realistic result, I know that, but it's the closest I've come so far. And even though it's not realistic, I think it's pretty cute. This is my first attempt, and this is my second attempt. So you can see this is sort of the development. I mean, yesterday, not a total. This is not the first attempt in total. Lots and lots more. Okay, let's start with a bit of comparison. Okay, there we have Blender. And those are the old material nodes. What I have done is I prepared the monkey and I gave it 4 materials. The mask material, which is just a black spot on a white monkey, shadeless. A regular material, which is just click the plus button, and a subsurface scattering material. And then I have the node material, which is supposed to combine the 3. Okay, let's duplicate this twice so we have our input. Move the output over here. This is just going to be the material. This is going to be the subsurface scattering material, and this is going to be the mask material. I want to mix the subsurface scattering with the normal material, so I'll just do that. And as a factor, I want to use the mask. I mean the black and white output of the mask, which is this. So right now, where it is black, the material on top will be shown, and where it is white, the material on the bottom will show. So let's change this because I want the subsurface scattering area to be smaller, and let's just give this a render. And you can see that the entire monkey gets... I'm sorry. Did I not... As you can see, the entire monkey gets done nothing, and also the output is black. Of course, I didn't check use nodes. Very clever. Okay, now you can see the entire monkey gets subsurface scattered. This is the pre-render for subsurface scattering, and subsurface scattering material gets applied, and I was wrong, it's applied where the black is, not where the white is. But that doesn't matter. The reason I wanted to show you this is you could see that the entire monkey head gets subsurface scattered in the pre-render, even though the material is only used in this black area. And so the more materials you mix together here, the longer your rendering time for this single object. The fortunate news is that this is not the case in cycles. So let's head over to the cycles material, and this I just left rendering, and this is my praying mantis with the light setup. And if I look through the camera here, you can see that both lights are in the view, but they're not being rendered. So let's have a look at that first. With every object, under the Object tab, you can check the ray visibility. So the entire Cycles rendering engine is, of course, ray or path tracing, so that's why it's called ray visibility. This is not seen by the camera, which means it just won't appear here, and it won't cast any shadows. It will, however, cast diffuse light. Even though this is seen by diffuse, it's not seen by the camera because it's emitting diffuse light. I hope that makes sense. And since it is seen by glossy, it will reflect in her eyes later on. You can see what I had here. The reflection was way too strong, but this is actually the light that's not seen by the camera reflected in the mantis eyes. Okay, So we covered this. Let's create this material again. I don't want to confuse you by going all over all these nodes. It's a lot easier to follow me if I just replace the nodes. Okay, now they're gone. So let's create a new material. And this is the Mantis tutorial blend. It's not the first time I'm recording this. So I can just save over that. Okay, let's get an input text, a texture, image texture. We can do the same from over here in the texture panel, but that used to crash Blender. So I'm using the Shift A menu from the nodes, and actually you can do a lot from over here, but I think it's easier to stick to one. But there are a couple of things that you can change over here. For example, if I wanted to transfer this diffuse node into a translucent node, I can't do that from over here in the node menu, but I can do it from over here. In the node menu, I would have to press Shift A and then uh, add a new one and delete this one. So let's connect the texture, and of course our image is gone, and that is because the texture is empty. So I'm going to use the where is that? Painted TIFF. For some reason, the PNG that GIMP gave me after I've been color correcting this did not get recognized by Cycles. I have no idea what was going on there, but just in case you run into the same problem, you have a texture and it's been seen, still your object is black, try changing the texture to a TIFF file. Just my experience. Okay, I want this texture to be mapped by UV. You can see the UV is default anyways, but just in case you're uncertain, there's two ways to do that. Shift A, input, and then texture coordinate, or you can just choose UV from down here. And I just realized, does this version have screen keys? Apparently not. Screencast key status tool, there it is. Okay, now you can see down here, yeah, you can see what I'm pressing. Very handy for me and for you, I guess, as well. Now, if you have a look at the Mantis right now, you can see that it's very, very bright. However, in the Photoshop version, it was not nearly as bright, even though I had some add shaders involved. So, the reason for that is the diffuse material, for some reason, is really bright. In theory, if I change this diffuse material to a glossy material that has a maximum glossiness, then it should have the exact same effect. However, this is a lot darker. So the diffuse material is, I think it's not physically accurate. I'm not sure, but usually when I use this, it gets very bright. It's just something to keep in mind. So let's change this into a translucent material. You can see this makes it a lot darker even more. So, and in fact, if I disconnect this light, you can see that the diffuse material is hardly visible anymore. But if I change this into a diffuse light, the Mantis is overexposed even. So we'll have to find a couple of workarounds. First, let's start off with the material setting itself, and then we'll get to the lighting part. Okay, I'll change this back into the translucent material, and Shift A add a shader. This used to be closure, but if this says closure in your version, please go and download the latest one. And let's add an add shader. The add shader is not physically correct, so the add shader will actually cheat in the brightness of your material, which is almost the same thing as this slider over here does. You can change the intensity, even though this is white. If it doesn't get any light from the lights, it's still black, and you can easily manipulate how bright your single objects are, or individual objects. Okay, you can do something similar to that with cycles as well, which is great. Because a lot of the times it's really hard to light situations. I mean, if you have lit a photographic situation for a camera, you know how hard this can be and how many different lights you might need for that. So what I'll do is I'll simply drag the translucent material into the add shader twice, and that will brighten up the entire mantis. So this is one handy trick. If your object gets too dark, you can add its material to itself, making the object brighter. Okay, that's the first hint. And the last time I already talked about the light path is transmission rays. So this light path option you can get by Shift A, input light path. And I can just delete this one because it might be a little confusing. And if you set the input of the light path to be the strength, you can still have control over the color of this. If you want to see what the light is doing exactly, you can change this to green, and you can see that this light is actually lighting up those parts of the praying mantis, which is great. But if you just have the transmission ray connected to the strength, you don't have the option of changing the strength. So what you'll do is add a converter math node and just multiply this by whatever value seems best to you. I took 20. So let's change this back to be a white light. And let's have another look at the material. I wanted, because I think it looks very nice, I wanted to have an edge. I hope this is the English word. It's when you have, actually I can show you, this light stream here. I'll call this an edge from now on. You have when a backlight is actually lighting your scene, then you get this nice edge. There are some more examples. For example, this one, you can see that wherever there's a translucent material, you get this nice edge going. Same with insects. You can see over here, it's a white line and it's not visible over here, and that is because of the backlighting situation. Same here. So I wanted this with my mantis, and I had to realize that it wasn't all that easy. Now this is sort of fairly close to what I'm going for, and I thought, wow, this is great, I'm almost done, but this material on its own, just a little modified, just didn't do the trick. So I had to come up with some more solutions. And one way to fake this, well, actually, if you wanted that light, if you wanted the physical attributes of that light, you'd need a translucent material and a lot of backlight, and that would do exactly that. Problem with the translucent material is the entire mantis gets sort of dark, and also there is no light from the back. And even if I delete this light, you can see that it's still not getting this nice edge that I wanted to have. There is a solution around that. It's sort of cheating, but I mean, that's what the tutorial is for. So let's use it. I can now, for example, add a new shader and I'm using the diffuse this time. And I'm going to add a shader, mix shader. And the mix shader, of course, mixes together the two materials. Now, because of my very bright backlight, the translucent material should actually be brighter than the diffuse material, but that's not the case, so we'll have to cheat our way around that. So right now, our added translucent material is mixed 50-50 with the translucent material. And now I want to change that. I don't want a 50-50 mix because that's just plain boring. So here's the way to change that. And I'm going to do that with an input Fresnel. Now, as some of you might know, Fresnel was a French physicist who had a lot to do with refraction and lenses and reflections. So I thought when I first read that this is a Fresnel node, that this node actually does something physically correct, but it does not. It is simply dependent on the normals, not on the light source. But let's show you what I mean. If you want to test what a material is doing, then it's always a good idea not to use two materials of the same color, because then you can't really tell what's different. So I hold Control and cut through these two nodes, and I'll give this a green material, and I'll give this a red material. So now, right now, since this is a 50-50 mix, our material should look slightly brown, but I should probably also use two diffuse nodes, because the translucent node just has a very different material setting and or lighting attributes, so it might confuse us still. Okay, now you can see this is all a brownish yellow, which is the exact mix out of green and red. And if I now take the Fresnel and put it in here, you can see that there is a slight red line forming around the mantis edge, which is exactly what we want, but it's very, very decent and it's very, very subtle. Actually, let me turn off the camera depth of field, because the depth of field is taking a lot of render time. So if you close your aperture, the opening size to 0, then the depth of field is gone. Well, as soon as I move something, I guess, then the depth of field is... Probably this is not the active camera. I was correct. This was not the active camera. Okay, now the depth of field is gone. Just a quick introduction, sorry for the intermission. Blades is, this will mean bright light points in the background will be unsharp pentagons, sorry. And this is of course the distance of the object in focus. Okay, and this is the rotation of the pentagons. And okay, let's get back to the praying mantis and the Fresnel effect. You can see that this part is sort of yellowish. That means over here the Fresnel node must be grayish. And that's because you remember a 50-50 mix of the two makes this yellow color, and a middle gray, 126, 120, 128, 128, 128, in those values here, in those values, or 0.1, 0.5 in this case, 0.5 in all those colors is middle gray, which means exactly 50-50 mix. So the IOR index over here determines how broad the edge of light is going to be. So if I set this to like 2, the effect will be a lot more widespread. But you can't really see the effect, but of course I do want to see it, so let's add another converter math node. If I add this, then of course black will be turned to middle gray, and white will stay white, and middle gray will be converted to be bright white. So this of course is not what I want. I want the black parts to stay black, so I use a multiply. Because 0 multiplied by any number is still 0, and black is exactly 0. But multiplying by 0.5, of course, is the same as dividing by 2. So I'll change this up to 4, and now you can see our subtle edge effect is starting to be a lot less subtle. You can actually see it. If you change this to 1.1, then the edge gets smaller again, as I said. And this is actually too small for my taste, so let's change it to 1.3. And now we have a nice edge going around that. And the edge over here is not physically correct. And if I move the light source, I could make the tests again, but I'll just show you the ones from the previous render. No, I did delete them, sorry. But the thing is, I'll print the screen, because otherwise you can't see it immediately, and I'll just move this light source. And if this was a physically correct effect, then the red edge should move with it. So I'll create a new file and paste it here, and let's have a look over here, and by now it should be done rendering. The effect is not very visible, I'm sorry I forgot that, if you don't have diffuse light turned on. So I'll just turn this up. This is the ambient light, nothing gets darker, gets less light than this, and actually let's change this down to 0.3, that should do. Okay, this is the praying mantis by itself, and this is the praying mantis with the light source at the original place. So if this was physically correct, there should be a big difference between the two. Let's check if there is. Let's print this again, put it on top, and of course it looks like a big difference because the light source is shining onto the head and there it's shining onto the side, but if you carefully look at where the red is, not how bright it is, you see it doesn't change at all. So this Fresnel effect is not physically correct, it is depending on the normals of your object. I don't know if there are plans to make this physically correct, I hope so, but for now it doesn't matter. Okay, so let's just delete this material and connect the image, the color of the texture, connect them back to our materials. Okay. And we're back to where we were. Okay, now you'd think that the translucent added to itself and with a lot of backlight would be brighter than the diffuse material, and if we were physically correct, then we'd have to mix the translucent material with the factor of the Fresnel. So where the Fresnel is, it should be brighter, and that's where, in theory, the translucent material should be. It's not the case, so we'll cheat again, and we use the diffuse material where the translucent material should be, and change. Why is this red? To be honest, I don't know why this is red. Okay. Red indicates a loop. That means if you have a material as an input to itself, the band turns red, and I think it's disregarded. But now, Blender is always compositing on top. That means this material comes first, and then this one gets mixed in. So it's the opposite of the layered version like After Effects. So this one is same with textures, by the way. This one is composited first, and then whatever factor is used, this one is composited on top. So right now, the Fresnel is white at the edges and actually black at the normal part of the mantis. So this is just inverted because the diffuse material is unusually bright. Now I want to sort of finish this off, and if you've seen the last tutorial, I think I'd have to show you in this version of Blender because the texturing does not work at all in the cycles build of Blender. So let me just textures, nope. Okay, this is an older version of Blender, or actually not older, but it's not a cycles build. This is where the materials work fine. This is how I painted the mantis, and now I can show you another mask that I painted, and this would be the mask. Now I originally used this to mark the areas that should be translucent with values between white, gray, and black. So, but this didn't work very well, so I actually used the Fresnel input instead of this mask. But what I did use is my spec map, and you can see that this spec map is only gray over here because I want sort of a speck to occur over here, and the eyes should have actually be a little glossy. So of course there's no specularity settings in Cycles anymore because they're not physically correct. The specula is actually sort of reflecting a lamp or pretending that the lamp was a reflectable object, even though it's invisible in the renderer. And you could, of course, in the Blender materials set how big the reflection of the lamp is, but not the shape. So in Cycles, of course, this is physically accurate or unbiased, mostly unbiased. This is where you can actually set, take into respect the shape of the lamp that is shining onto your object. So I'll add another shader mix node. I'll add another texture node, image texture, and for this one I'm going to choose the specularity map. And then I need a third new node, which is another shader, glossy node. Okay, if I just use the glossy node for the entire mantis, then this is what she'll look like. There is nothing to reflect except the lights, so she's reflecting a black environment and those two lights. Okay, so this is of course not what we want. We want the glossy to be mixed in with the material, and we want it to occur only where the eyes are. So this is our original material, and the glossy is now composited on top 50-50, just as the Fresnel effect was before. So I'll take the UV input for this image texture, and also oops, that was wrong. The glossy, of course, needs the texture of the original texture, because the eyes are still part of the original texture. Now all you can see is that the glossy parts get very bright and the rest gets very dark, because this is just a simple mix. But if I use the texture that has only the eyes covered in white as a factor, then the glossy part should only appear where this texture is white, which is on the eyes and a little bit on the back legs. That you could see, wrong one, over here. Okay, this is way too glossy, so I'll increase the roughness, put it to something like 0.6, should do. Still too bright, so 0.8. And now we actually have the node set up for the entire mantis. Let's have a look at, check if, there we go, this is what rendered overnight. Let me stop this rendering process over here. And you can see that the mantis itself is getting a nice light from over here. I'm disregarding that these teeth, or these zigzags, or spikes, that's a good word, should not be that bright. That is because of the Fresnel effect. Same issue we have over here. And also we'll have a little bit too much on the head. And actually these come from a normal map that I baked. There's a lot of tutorials on how to do that, so I'm not going to go into that. So the part I like is actually this foot, because it looks nice and transparent. I like this edge over here. I like the edge on those what will be wings, because this is still a juvenile praying mantis. And I think the specularity on the eyes should be a little more, but this is still something I like. I don't like that this is too dark. I don't like the two white parts on the spikes, and I of course don't like the graininess of the background. And this is also a little overexposed. The problem with the graininess is that I have two different light sources, and apparently Cycles can't really handle two different light sources yet. This has been rendering for 10 hours and 26 minutes and still very, very grainy. Of course, this is partly because of the depth of field. Depth of field takes a long time. You probably still know that from the Blender compositor. Depth of field nodes that are very blurry took a long, long time to composite. And this is the same here, but the graininess of this and somewhat of this is also due to the two light sources which sort of battle each other in the casting of the photons. Photons? I guess that's how you pronounce it. So even with a more simple scene, as soon as you add two light sources, you'll see that there's a lot of fireflies, a lot of grain, but I'm fairly certain this will be fixed in other versions of Cycles very soon. So I'm not going to worry about that. I'm still going to make my light setup regardless of how grainy it looks in the end. And the setup for the flowers are basically just um, slightly altered material of the praying mantis, except for the petals. I also painted all of this myself. It was a first try and I think it looks okay. And this oversaturation is, I think, due to an add node that I might change. But I guess this is it. This was Cycles material on how to use nodes for complex object and for complex rigged materials. A little bit of theory put inside, and I hope you learned something. I hope you can use this for your project. And I guess I'll see you next time. Thanks for watching.